Let us look at this preamble before we get started with the learning outcome. I would get started with the law of demand. The law of demand states that all else being equal, as the price of a good increases, the quantity demanded decreases. So what I'm saying in essence is that price is inversely proportional to quantity demanded. And this is very logical because as the price of a good increases, such good becomes less affordable, thus the quantity demanded would reduce. To represent this relationship using a graph, on y-axis we have price, then on x-axis we have quantity demanded. Since we are dealing with an inverse relationship, then we should have something of this nature. Let us assume that we have P naught here and we have Q naught here. So Q naught is the original quantity demanded, P naught is the original price. If the price should increase, so let's call this P1, then what will happen to quantity demanded? Quantity demanded will reduce. So let's call this Q1. Now moving on to the law of supply. The law of supply states that all else being equal, as the price of a good increases, the quantity supplied increases. So what I am saying in essence is that the price of a good is directly proportional to the quantity supplied. And this is logical because I would obviously want to supply more goods at a higher price. To represent this relationship on a graph, imagine on y-axis we have price, then on x-axis we have quantity supply. Then the graph will look like this. So as the price keep increasing, what will happen to quantity supplied? The quantity supply will also increase. Elastic demand. Elastic demand refers to a situation where the percentage change in the quantity demanded of a good is greater than the percentage change in its price. So that we are all on the same page, let us assume that we are dealing with smartphones. Also, let us assume that the original quantity demanded for a particular smartphone is 100 units. But recently, the quantity demanded increased to 120 units. Also, let us assume that when the quantity demanded was 100 units, the original price per unit was, let's say, 1,000 US dollars. We agreed on the previous slide that price is inversely proportional to quantity demanded. So since quantity demanded is up, then we will expect price to decline. So that implies that the new price per unit will decline. For assumption's sake, let us assume that the price declined to 900. The percentage change in quantity demanded would be 120 minus 100 units divided by the original, which is 100, and that would be 20%. To compute the percentage change in price, it will be the new price, which is 900, minus the original price, which is 1000. Then divided by the original price, which is 1000, I expect it to have negative 10%. Neglecting the signs here, that is focusing on absolute figures, from here, you would agree with me that the percentage change in quantity demanded is greater than the percentage change in price. In such situation, we would say that the demand is elastic. So that we are all on the same page, and also to summarize what I've discussed so far, if the percentage change in quantity demanded is greater than the percentage change in price, obviously focusing on the absolute figures, then we would say that demand is elastic. Inelastic demand refers to a situation where the percentage change in the quantity demanded of a good is smaller than the percentage change in its price. Here, let us assume that the original quantity demanded was 100 units, but now the new quantity demanded is, let's say, 120 units. The original price per unit, let's assume it was 1000 US dollars, but now the new price is, let's say, $700 US. To compute the percentage change in quantity demanded, it would be 120 minus 100 divided by 100, which is 20%. To compute the percentage change in price, it would be 700 minus 1000 divided by 1000, and that will be negative 30%. We need to neglect the negative sign because our focus is on absolute figures. So here, the percentage change in price in terms of absolute figures is greater than the percentage change in quantity demanded. Or we could rephrase it as the percentage change in quantity demanded, which is 20% in this case, is smaller, is lesser than the percentage change in price, which is 30% in this case. An example of this is essential medications. Essential medications remain in demand despite price increases. Let us look at extreme situations of inelastic demand and elastic demand. I'll get started with inelastic demand. An extreme situation of inelastic demand is what we call perfectly inelastic demand. Here, the quantity demanded remains constant even as price keep changing. Whether it goes up or it comes down, the quantity demanded will remain the same. So that implies that if you compute the percentage change in quantity demanded, it will be 0 since it is fixed here. It doesn't change. The quantity demanded does not change. But if you compute the percentage change in price, it will not be 0. So that implies that looking at the absolute figures, I will expect the percentage change in price to be greater than the percentage change in quantity demanded. But this is a special situation because the percentage change in quantity demanded is 0. Moving on to a special situation, an extreme situation relating to elastic demand. Here, it is price that does not change while the quantity demanded could go up or come down. So that implies that quantity demanded changes but price does not change. So here, the percentage change in price will be 0, but the percentage change in quantity demanded will not be 0. So that implies that the percentage change in quantity demanded is greater than the percentage change in price. But this is a special situation, is an extreme situation because the percentage change in price is 0. Fixed cost and variable cost. This is particularly important to those that are new to economics. Let us get started with fixed cost. These are costs that do not change with the level of output. An example is rent. Imagine you rented a building at the beginning of the year and the building is to produce several units of a particular output. Imagine at the beginning of the year you produce 10 units, then during the year you decided to increase the unit to, let's say, 20 units. The question is, will your rent increase at least in short term? The answer is no. Your rent will not increase at least in the short term. So your rent will not increase despite producing more units. So fixed costs are costs that do not change with the level of output. So the unit had gone up, but your rent remained constant, at least in the short term. Variable costs, these are costs that change with the level of output. An example is wages. Imagine at the beginning of the year, you produced 10 units and you employed several individuals to produce these 10 units. Let us assume that you paid them $10. Now, during the year, you decided to increase these 10 units to, let's say, 20 units. It is obvious that what you would pay them would increase. So let's say you pay them $20. You can deduce that the amount you pay them changes with the level of units. So the higher the level of output, the higher the cost. So the example I have painted here is variable cost. In economics, we often say short run and long run. The short run is the period during which at least one factor of production is fixed. The factors of production include technology, capital, plant size, etc. The long run is the period during which all factors of production are variable. Let us briefly look at this table. I have divided this table into 3 categories. profit, revenue, and cost. So let us get started with category 1, profits. To be more specific, economic profits. Economic profit is equal to total revenue minus total economic cost. The total economic cost is equal to the total accounting cost plus implicit opportunity cost. The implicit opportunity costs relate to foregone alternative. Moving on to category 2, let us get started with total revenue. Total revenue is equal to price times quantity. Let us assume that the quantity is, let's say, 10 units, and the price per unit is, let's say, $12. To compute the total revenue, it will be the quantity of 10 units times the price of $12. If you solve for this, I expect you to have $120 US. Average revenue is equal to total revenue divided by quantity. So that we are all on the same page, let us assume that we have period 1 and period 2. Let us assume that in period 1, the total revenue is 70 and the quantity is 1. Also, let us assume that in period 2, the total revenue is 140 and the quantity is 2. To compute the average revenue, it would be the total revenue divided by quantity. Let us assume that we're interested in the average revenue for period 1. It would be 70. 70 is the total revenue divided by the quantity, which is 1, and that would be 70. Marginal revenue is equal to the change in total revenue divided by the change in quantity. Marginal revenue, by definition, is the extra money a firm earns from selling one more unit of output. To compute the marginal revenue for these two periods, marginal revenue is equal to the change in total revenue divided by the change in quantity. The change in total revenue would be 140 minus 70, that's coming from here, divided by the change in quantity, which is 2 minus 1. If you solve for this, I expect you to have 70. Total fixed costs is the sum of all fixed expenses, including opportunity cost. Fixed costs are costs that remain constant regardless of output. The total variable cost is the sum of all variable expenses, or we could just simply say that it is per unit variable cost times quantity. This can also be called the variable cost per unit. So variable cost per unit times quantity will obviously give us the total variable cost. Average fixed cost is equal to total fixed cost divided by quantity. Average variable cost is equal to total variable costs divided by quantity. Average total cost is equal to total cost divided by quantity. Or we could just simply say that it is average fixed cost plus average variable cost. Marginal cost is equal to the change in total cost divided by the change in quantity. By definition, marginal cost is the extra cost a firm incurs from producing one more unit of output. So that we are all on the same page, let us assume that the total cost in period 1 is, let's say, 70, and the quantity in period 1 is 1. The total cost for period 2, let's assume it is 140, and the quantity in period 2, let's assume it is 2. So to compute marginal cost will be the change in total cost divided by the change in quantity. So the change in total cost will be 140 minus 70 divided by the change in quantity, which is 2 minus 1. So if you solve for this, I expect you to have 70. If you are struggling with these two definitions, I have the definitions here. Let us move on.